Hey guys, so this is video 2. So we're doing the second question. Now we're trying another problem. So this says a restaurant serves pie. Each table gets 2 pieces of pie. The chef is able to combine these 2 pieces to make wholes with no leftovers. How many dishes did he combine? So I'll let you guys see the problem now. So the first thing that we're going to do is circle the important parts, underline the important parts in the word problem because we always read a word problem twice. So a restaurant serves pie. That's not really important. Each table gets 2 pieces of pie. That is important. The chef is able to combine these pieces to make 2 wholes. So we're going from 2 to 2 wholes with no leftovers. That's super important. How many dishes did he combine? Okay, so that's our question. How many dishes did he combine? So they're not looking for us to say 2 wholes because we already know that that's in the problem. And they're not looking for us to say 2 sixths because that's how many pieces of pie each table gets. They're looking for a solid number of how many dishes the chef needs to count from each table. Basically, how many tables did he serve? 2 to make 2 whole pies. So this is another one that we're going to draw out, and I'm going to draw this one out in real time. He's making these 2 pies, right? And he's going to split them into 6. So I'm going to do my best to do that. And I'm going to color each table's 2 sixths, so each one that the table gets, each 2 sixths that the table gets, a different color so that we can see it visually. So here's the first 2 sixths, that's 1, that's 2 sixths right there. Now let's use a different color. Here's the second one, that's 2 sixths right there. Here's the third one, that's 2 sixths right there. The fourth one, oh, I can't get my marker open. There we go. 2 sixths right there. Here is another one, 2 sixths. I'm running out of marker colors, so excuse me if I use a color twice. And here's another 2 sixths. So the question is, how many 2 sixths do I have? That's what he's looking to see. So I'll number them. Here's my first one. Here's my second. Here's my third. Here's my fourth. My fifth. And my sixth. So he's served 6 tables. So if we were to answer this question, I would write 6 dishes total. All this is asking is, how can I make two whole pies using just 2 sixths? All the last question was asking is, what is the smallest number that divides into 4? Because 3/4, the bottom number is 4. They were looking for the next one, how many 3/4 makes a whole? It's just, does 3/4 make a whole? No. Does 6/4 make a whole? That's the multiple of 3. 3, 6, 9, the top number. 3 doesn't. 6 doesn't. 4 doesn't go into 6 evenly. 9 doesn't. 9 doesn't go into 4 doesn't go into 9 evenly, correct? So does 4 go into 3 evenly? No, it can't. Does 4 go into 6 evenly? No, it can't. Does 4 go into 9 evenly? No, it can't. Does 4 go into 12 evenly? Yes, it can. That must be the smallest number, that 3/4 added up many times, that makes a whole. So for this one, we were working with 2/6. I'll use different color markers so that you guys can see it. Does 6 go into 2 evenly? No. Does 6 go into 4 evenly? No, 6 can't go into 4. If I have 4 pencils, I can't hand them out to 6 kids. Does 6 go into 6 evenly? Yes, it does, but that only makes one whole. We can only make one pie with 6 out of 6 slices. We need 2 pies. Does 6 go into 8 evenly? No, because if I had 8 pencils and 6 kids, I can't give out those other 2. There'd be leftovers. Does 6 go into 10 evenly? No, because again, if I gave everyone 1 pencil, I would have 4 left over, and I can't give out 4. I can't pick 4 kids to hand those pencils out, and 2 kids get left with just 1. So let's try the next one. Does 6 go into 12 evenly? Yes, it does. 6, 12. That's 2 wholes. That's 6 plus 6. So we have 2 6 over 6s. That makes 2 wholes. So 12 out of 6. There's 12 out of 6 slices to make a whole. And because they're using 2 6 over and over again, it's 1, 2, 3, 4, 5, 6. 6 tables. We have 6 2 out of 6s over and over.
Please excuse the interruption. All